I'm going to give you some background information about topographic maps, which will help you in your lab. This topic tends to be sort of challenging for students, and so giving you some information before you walk in the door will certainly help you to handle the material better. So what are topographic maps? Topographic maps are simply two-dimensional representations of a portion of the three-dimensional surface of the Earth. So what does that mean? So it's basically, how do we show the changes in topography or the changes in elevation on Earth just using a sheet of paper? So what you're looking at here, this top image, is showing contour lines, showing changes in elevation for this actual image below. So what we have here is a small little volcano called a cinder cone, and so it has this conical shape with a depression in the middle. And so these contour lines, each line represents a specific elevation. And so when you see them all piled up like this, it's telling you that you're changing elevation pretty quickly in that area, say compared to a flatter area here where the contours are farther apart. So just here are some images of what topographic maps look like with a slight shading to them. So up here you can see different contours. The resolution's a little bit low, but you can see closer together contours, farther apart contours, and then some water. This is showing maybe a large mountain top with a flat top to it. Here is an image trying to show you, okay, if this is your little island out in the middle of somewhere, you would draw contours for each specific elevation. So this is every 25 feet. And then if you were to look down in map view or bird's eye view, you would see these contours kind of drawing irregular circles showing that island shape. All right, so when we look at maps, we often look at what are called topographic quadrangles. So to put that into reference, these are sections of the Earth that are bounded by latitude and longitude. So going back, remembering latitude and longitude are degrees. So latitude lines run east-west, and longitude run north-south. And so you can see the longitude lines actually close in on each other at the poles. The latitude lines are always parallel to one another. So we go from degrees. In each degree we have 0 to 90 for latitude, 0 to 90 degrees north and 0 to 90 degrees south. And then for longitude we have 0 to 360 or 0 to 180 west, 0 to 180 east. We break the degrees down into minutes. So each degree has 60 minutes in it, and each minute has 60 seconds in it. So the latitude and longitude of Houston is 29 degrees 45 minutes north and 95 degrees 22 minutes west. So if we were to find that on here, we said 29 degrees 45 minutes north. So we come all the way up to about here, because here's 40 and here's 20. So we're somewhere, 29 is almost halfway. And then 95 degrees 22 minutes west. So if this is 0, our prime meridian, which is in the UK, we have to come all the way over to 95. So almost to there. And we're going to plot it. So Houston is about somewhere like that on this globe. All right? So each topographic map is taking some small portion of the Earth. We have topographic maps that cover the entire Earth. So there's a whole bunch of them. So how do we do that? So topographic quadrangles are bounded in the top by these lines of latitude, and on the east and west by longitude. So again, just to remind you, in each degree we have 60 minutes, in each minute we have 60 seconds. So if you were to take this little section of the Earth and zoom in, you could look at maybe 15 minutes by 15 minutes. Then if you were to zoom in even more, you get what's a 7.5 minute by 7.5 minute quadrangle map. And most maps that you'll see are actually these 7.5 minute quadrangle maps, which means that they span 7.5 minutes of latitude and 7.5 minutes of longitude. All right, so general information, when you're looking at these maps, there will be what's called a map scale. We'll talk more about that soon, but basically, how far is it a kilometer actually on this map, and those sorts of things. The vertical scale, which refers to your contour interval. So topographic contours or contour lines show elevations on the map. So in very flat areas, you might have contour intervals that are every foot. So you're drawing a change in every time you change elevation a foot, you would draw a line on the map. In very steep areas, you can't draw a line every foot. So they might do something where it's every 40 feet, something like that for contours. So keep in mind, contour lines are simply these lines that are just a series of points that are connected of equal elevation. So if you were to walk along any of these contour lines, you're staying the same elevation. And these elevations are above sea level. So we'll look at that more. So let me just go back to remind you, when we're talking about contour lines, looking at this map, or any of these maps, any of these lines, if you were to walk on it, is the same elevation all along that. To go from here to here, you're changing a certain amount. That's called the contour interval. I'm not sure what it is. I think for this map, it's every 20 feet. So every time you go from one line to the next, you're changing 20 feet in elevation. This one has every 25 feet. So it just depends on what map, and you can look at it and figure that out. Okay. So what are some rules for contour lines? So these are things that once you spend more time on them, you could write these rules yourself. But basically every point on the contour line is the exact same elevation. So contour lines connect points of equal elevation. When you're creating, you will in lab have to make topographic maps and draw contour lines. And the thing to keep in mind is, when you're drawing this contour line, you're going to separate points of higher elevation from points of lower elevation. So if you're drawing a 100-foot contour, you're looking for elevation points that are on one side of the line going to be higher than 100 and on the other side lower than 100. And so that's what you will just be looking at, the adjacent elevations around your line and trying to draw that. Contour lines ultimately always will form some sort of circle, but sometimes that circle runs off your map, so it doesn't completely form the circle, but somewhere it would close. So the elevation between any two contour lines is what's known as a contour interval. So a lot of times you'll see that every fifth line is actually bolded. We call these index contours, and they usually have the elevation shown on them. So I'll just skip back to here, and you can see that certain lines, see how this one is bolded, and then this one is bolded, and then this one is bolded. So that's the first. So you have, here's a thing, then you go count 1, 2, 3, 4, 5. So every fifth one is bolded. Those are our index contours. All right. Oops, sorry. Through that. So contour lines will never cross themselves. There's one exception, which is a cliff. But for the most part, they can't cross themselves. And if you think about that, you say, well, why? Well, contour lines represent a specific elevation. So if a contour line represents 100 feet and another contour line represents 80 feet, they should never cross each other, because if you were to think about, well, what would that mean on the surface of the earth? You can't really have a point that's both 100 feet above sea level and 80 feet above sea level and still be on the ground. So they should never cross each other. They also should never merge. So an 80 and 100 shouldn't just come together and form one line. And then another rule is just if the slope of the area is a very even slope, then the contour line should be regularly spaced. So keep in mind, the closer the contour lines are, that's the steeper the slope, okay? And then the farther apart they are, the more gentle the slope. So if you see a concentric series of closed contours, this represents a hill, shown here. If you see contours that are closed, but they have these little, what we call hatcher marks, that's showing you that it's actually a depression, like a little basin or a bowl shape. One thing that will really help you, it will come up on lab, is recognizing contour lines and the V pattern that they make with streams. So when a stream flows downhill, it typically erodes the area. And so the stream flows in the local low spot. And so what happens is the contour lines actually show that stream, how it's flowing. See how these all sort of V upstream or uphill? So it's just basically this little depression in the area, and so they all V upstream. And so you can look at that. If you see the contours doing this little V shape like this, it tells you that the stream is flowing that way. This is something that you'll have to think about a little bit more to really grasp why that is, but think about, how that could happen. All right, so when you're crossing a valley, contour lines will always occur on opposite side, will occur as a pair on opposite side. All right, and so then topographic maps for the U.S. are typically in feet relative to sea level. Sometimes you'll find meters, which is much better, but most of our maps are in feet. So that pairs of ridges and valleys. So here is a ridge. So see this? So a ridge is just an elongate hill. And so these are your contour lines shown every 10 feet. The red line is just showing the highest point. But what you can see is you get to 250, you cross over the highest point, come back down, you hit 250 again. So you're repeating these pairs on either side. And the same thing happens with a valley. If you have this stream here, you have the 220 on either side. And that will come up in lab. And you can see every single one pairs. All right, so closed depressions, again, you will see that repeat happening. So if you're going up and then you're going back down, so you hit this 300, you go up and over, and you come back down and hit 300 again. So you have that repeat. Whoa. So here again, if you have a depression and you'll see something like this in lab, and then you're going back up, you can see you're hit 300, you climb up a little bit more, you repeat the 300, you have a 290, so here's your 300, but then you're climbing up some more, so then you hit the 310. So there's no repeat on that side. All right, so contour intervals, just to refresh, is the difference in elevation between two adjacent contour lines. And so we call this the CI, and so it varies from map to map. So when you first sit down to look at a map, make sure you figure out what the contour interval is. Usually it's written at the bottom of the map. Sometimes it might ask you to figure it out just by looking at the contours. So this is always referenced to mean sea level, and so mean sea level is an elevation of 0. So your map will have scales, and there are a lot of different scales, and I'll expect you to kind of be comfortable going back and forth between these. So a verbal scale is just one that's an example is 1 inch equals 1 mile on this map. You'll also see a ratio scale or a fractional scale, and this is something like 1 to 24,000, which means every unit on the map that you measure is actually 24,000 units in real life. So it's unitless. You pick the units, you just have to be consistent from one side to the other. So you could say every inch on the map represents 24,000 inches in real life, or 1 centimeter represents every 24,000 centimeters in real life. And so it's just basically how much you're multiplying it. So a bigger number means that the map is covering a larger area. All right, then the next is a graphic scale, which is something like this, where if you were to look at it and say, okay, from here to here is 100 kilometers, then you look at your map and you could use that to kind of look and see how far distances are. The thing I will warn you is that most maps, they tend to show 0 here and not over here. So they'll show 0 to some unit here, and then they'll do a smaller division over here. So when you go to measure the length for 100 kilometers, make sure you start at the 0. Vertical exaggeration is not something we'll touch on much in this class, but if you're making a topographic profile of an area, usually they make it the topography look more extreme. All right, so if you were to calculate gradient or slope, gradient is just the change in elevation between 2 points. And so it's just like math class. You figure out how much you're changing in elevation over what distance, okay? And so it's usually expressed as feet per mile. So how many feet are you changing over a mile? Okay, so topographic maps, when we're talking about, we're going to think about topographic profiles. So profiles are simply slicing through topography and looking at, what does this look like from the side? So a topographic map, we call that map view. A profile is a cross-sectional view. These are terms that will come up a lot in this class. Map view versus cross-sectional. So map, like you're a bird looking down on things. Cross-section is the slice, you're looking at the side view. All right, and so a topographic profile is looking at that side view. So if you have to create a topographic profile, so for here, we're looking from A to A prime, what this is wondering is, okay, if you were to look at a slice here, what does the topography actually look like along this line? So you would want to know this, say, if you were going out to walk the area. Where is it going to be steep? Where is it high? Where is it low? Where will the walk be easy? And so if we first just look at this, so from here to here, we start out, let's see, the contour interval. So here's a bold 100, here's a bold 200. The contour interval is about every 20 feet, or it is every 20 feet. So we start, this is 80, so this would be something slightly less than 80, and we end up at maybe 190. So we're going to have, overall, we're going to have to go uphill. You can see we're climbing uphill here. We're going to come downhill, hit the stream, so into a little valley, and then we climb uphill, 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 uphill to the end. And we're going to have our steepest topography downhill right here, very steep, and then steep uphill here. So if you were going to create this topographic profile, what you would do is you take a little strip of paper, because remember, we want to draw what it looks like from the side. Take a little sheet of paper, we'd mark A and A prime, and then we'd mark everywhere where we intersect these contour lines. It would make a note of their elevations. Okay, so it would look something like this. All right, so you'd go along and mark those elevations and see how this little hill we're repeating. We're repeating on the hill, we're repeating on the valley. Okay, so this is just putting it into words what I just said. All right, so then you take those points and then you would transfer them onto a sheet of paper. So you've got all your little tick marks. You set up a scale here, and then basically it's just plotting. You say, okay, well, I need to be at 80 at this point. So you go straight up, you find 80, and you mark a point. Here is 100, so you go straight up, mark 100. And you put all the dots, and then you go back and you connect the dots. And what I'll point out is when you hit, let's say, a hill, you don't just go 100 to 100. You show that, yeah, there's probably some elevation higher than that. We don't get all the way to 120, but it is a rounded hill. Same with the stream. This is where the stream is, so that should be the low point. All right, and so here now you can see, yeah, the topography is steep here if you're coming down, and then there's a big long hike uphill. Okay, so that will be the last part of your lab. And so this is, again, just bringing that all together. I'm going to also post a short video on how to show how to create a topographic map that a friend of mine made that will help you. But here is kind of what a topographic map looks like with all these details. You won't worry so much about it, but the things I want to point out is, you know, you can see the latitude and longitude shown for each corner of the map, where the map occurs. Here's the scale bar, so we've got a fractional or ratio scale here and a scale bar shown. Okay, typically maps north is towards the top of the page, and then this shows you where it came from. Okay, a lot of this other stuff is just extra chaos that will confuse you, but here you can see these contour lines and things like that. So I hope this gets you started for the lab for topographic maps. Thank you.